Welcome to the video on correlation and line of best fit. First, we'll talk about correlation. So Pearson's product moment correlation coefficient, or R, is the measure of the linear relationship between two variables. So it's only meaningful for linear relationships. So to calculate what R is, and to also calculate the line of best fit, which we'll talk about later, you would go to Stat, Edit, and enter the data into L1 and L2. So first we'd have some table, like shown on the right, that shows two different variables. So here we have the temperature in degrees Celsius and the number of ice cream cones purchased. So we would take all that data and we'd enter it into our calculator. So it would look something like this. Then we would go to second 0, which is catalog, and scroll down to where it says diagnostic on and hit enter. You only need to do this the first time, but this is how you make sure that your results will show your correlation coefficient. Then we'll hit stat, calc, linreg, ax plus b, so that's for linear regression. And then you'll make sure it has the correct lists in, so if you entered them into L1 and L2, you'll make sure those are the lists selected there, and then you'll hit calculate. So your results will look like this right here. So this is your linreg results. So it says y equals ax plus b, and then it gives you an a and b value. So your line of best fit would be y equals a, which is 3.011 times x, plus b, which is 2.105. So this would be your line of best fit, which we'll talk about later. And then you have your R value down at the bottom. So it says R equals 0.957. So the closer the absolute value of R is to 1, the stronger the linear relationship. So you can tell here that this has a really strong relationship. And since it's positive, it means as our X increases, our Y is also going to increase. So as the temperature increases, the number of ice cream cones purchased is also going to increase. If it was negative, it would be an inverse relationship. And if it was close to 0, there would be hardly any relationship at all. So here we have some scatter plots. A scatter plot is a graph of dots representing one variable versus the other. So you'd have your X variable and your Y variable, and then you would put your points on here. A line of best fit is a line that best describes the relationship between the variables. So your line would go through your median, and it would give a good overall feeling for what the relationship is. So you can draw a line of best fit just by using your eye, or you can calculate your line of best fit like we talked about in the previous slide. So our first graph up here shows a positive correlation. So R would be greater than 0 because as X increases, Y is also increasing. Our second graph right here is a negative correlation because it's going down. And this third graph has 0 correlation, so R would be approximately 0 because the points just seem to be scattered all over the plot. Down here on the bottom, our fourth graph shows a strong correlation because all the points are close to the line. So this would be an R value of close to 1. You could also have a strong correlation going down. If all the points are close to it, our R value would be close to -1. For a weak correlation, your R value would be closer to 0, so they wouldn't be as close to the line as they would be for a strong correlation. So your R value could be around 0.2, 0.5, somewhere around there where it's not a super strong correlation. This final graph shows no correlation, so R would be approximately 0. The points are all far away from the line. There isn't really any relationship at all. So this shows correlation, but correlation does not necessarily mean causation. So just because you can see a positive increase or some sort of trend, it doesn't mean that one thing is causing the other because there could be different variables that are playing a role into this. So now we have our regression line or our line of best fit. This is our y equals ax plus b, where a is your change in y over change in x. So if we had our temperature versus ice cream purchases, this would be change in ice cream purchases per change in temperature. So it would be like the number of ice cream cones purchased per increase in 1 degree Celsius. Your B value is your Y value when X is 0. So if the temperature was 0 degrees Celsius, your B value would be how many ice cream cones are purchased at that temperature. So your line can be used to predict Y using X. So some warnings are extrapolation, which is inferring outside the range of the data. So this can lead to incorrect predictions. So if you had points from 20 degrees Celsius to 40 degrees Celsius, and there was some sort of trend, extrapolation would be making a prediction all the way down here using your line of best fit, but that may or may not be accurate because your trend might not continue outside of that range. Another warning is making a prediction of X from the value of Y is not always reliable when using a Y on X line. So you can't always put in Y and figure out X because we don't know if the relationship works both ways. So with these kind of lines, you would only want to use X to predict Y. So here we have our first IB practice question where the calculator is allowed. It says, for 6 months, a researcher tracks the number of ice cream cones sold and the number of shark attacks. Draw a scatter plot of the data, then calculate the correlation coefficient. Is there a correlation between ice cream cones sold and the number of shark attacks? Is there causation? So we'll draw our scatter plot. So we'll have ice cream cones sold on the bottom. And that ranges from 24 to 182. So we'll go up to 200. Then on our y-axis, we'll have number of shark attacks. Our title will put ice cream versus shark attacks. So our first point is 24.0. So we'd have a point about here. And we also need to label our y-axis. So our y-axis needs to go up to like 20. So we'll have 10, 5, 15. So our second point is 48.2. So that would be about here. Then we have 157.14. Around here. 164.19. So that would be like here. 182.15. Here. And then 104.8. So from looking at this, if we were to draw a line of best fit, it would probably be right about here. So it looks like there's going to be a positive correlation. To find out for sure, we'll go to our calculator. And in lists 1 and 2, we'll enter the number of ice cream cones sold and the number of shark attacks. Then we'll go to Stat, Calc, Linear Regression, and hit Calculate. So this asks for our correlation coefficient, so that's R. So R equals 0.965. So that's really close to 1, so that's a really strong correlation. So we would say, yes, there is a correlation between ice cream cones sold and the number of shark attacks. Then it asks, is there causation? So just because we found a relationship doesn't mean that one causes the other. Likely, ice cream cones sold does not cause shark attacks. So I would say no, there is not a causation. If we think about it, there's a good chance that shark attacks increase as ice cream cones sold increase, because when it's warmer outside, people will go swimming in the ocean, which would lead to shark attacks. And when it's warmer outside, people buy more ice cream. So there's some other variable that's leading to this relationship. So just because there's correlation does not prove that there's causation. So this would be the solution to your problem. Now we have our second IB practice question. It says a survey is performed to figure out the relationship between average hours of sleep a student gets versus their grade point average, or GPA. The results of the survey are shown in the table. Calculate the correlation coefficient and explain what it means. Write the equation for the line of best fit and estimate what someone's GPA would be if they get an average of 5 hours of sleep a night. So because we have the calculator, we'll start by entering our values into L1 and L2. Once we do that, we'll do second calc linear regression, and that will give us our correlation coefficient and our linear regression equation. So our correlation coefficient equals negative 0.104. So this means that there's a very weak negative relationship between the two variables. So because it's negative, that's why it's a negative relationship, and it's weak because it's almost zero. There's almost no relationship at all. So our line of best fit would be y equals A, which is negative 0.0483 times x plus b, which is 3.459. So now that we have our equation for the line of best fit, we can estimate someone's GPA if they get an average of 5 hours of sleep a night. So that would be y equals negative 0.0483 times 5 plus 3.459. So that would equal 3.2175. So someone who gets an average of 5 hours of sleep a night would likely have a GPA of around 3.2. So those are your answers to the question. We have our correlation coefficient and the explanation. We have our line of best fit. And then we have our approximation of a GPA for someone with an average of 5 hours of sleep a night. So in summary, Pearson's correlation coefficient, R, measures the linear relationship between two variables. We learned about calculating R in the line of best fit with technology. A scatter plot is a graph of dots representing one variable versus another. A line of best fit is a line that describes the relationship between the variables. For correlation versus causation, correlation doesn't automatically mean causation. Our line of best fit, y equals ax plus b, can be used to predict y using x. And we learned two warnings. Extrapolation, inferring outside of the range of the data, can lead to incorrect predictions. And making a prediction of x from the value of y is not always reliable when using a y on x line. That's all for this video. Thank you for watching.